Hello, everybody. Welcome to the first part in this series about college algebra. Today's lesson is going to be very basic, so I believe that just about anybody will be able to follow along with it. And to give you a little bit of background, I want you to think about maybe some things that you've done before taking college algebra. Maybe you've had problems like 4 plus 6, and you got to solve for what that is. So 4 plus 6 would equal 10. Or maybe you'd have something a little more complicated. Maybe you do something like, 6 times 2 times 3. So you would get 6 times 2, that would be 12. 12 times 3 would equal 36. But a lot of the time, when in previous math classes you would be working with numbers. College algebra, it's a little different. Algebra in general, it's different. Most of the time you're working with variables, and to help you understand what a variable is, I think I'm going to just give you a very concrete example. And this is something that I was working on before. So I write, Bill decides he's going to start a pencil collection. He already has 52 pencils in his possession when he makes this decision. Every year, he plans on adding 11 new pencils to this collection. Create a linear equation that describes the total number of pencils in Bill's possession, where the variable stands for the number of years that have passed since the initial decision to start the collection. So the expression we'd use to describe this would be 52 plus 11x. And if we wanted to really go with the idea of a linear equation, we would write something like y equals 52 plus 11x. I'll go more into what a linear equation really is in a subsequent video, but for now, I just want you to know that here we would consider x to be the variable, right? Because say if we wanted to indicate what he had when 1 year passed, right? Well, we would take this, we take our expression, and we take 52, we'd add 11, and then we would drop, say, if we want to see what he had after 2 years, we drop a 2 here where the x was. And when we put it in parentheses like this, when it's next to another number in parentheses, this means we're going to be multiplying, right? So this would turn into 52 plus 22, and then that would turn into 74. So we'd have 74 pencils after 2 years. And I wrote a linear equation here. Usually, like I said, I think I said this already, but we would maybe write like y equals 52 plus 11x, because that is a little more standard for a linear equation. But, so we have this. Say if we wanted to find out what he had after 4 years. So we do 52 plus 11 times 4. We just drop in the 4 where the x is. And then we would get 52 plus 44. This would equal 96. So you'd have 96 pencils after 4 years. Now, when I phrased this question, I made the variable stand for the number of years that have passed since the initial decision to start the collection. So in a certain sense, you can think of that exact time he started as year 0. That way, if we were to drop 0 into the equation, we would get 52 plus 11 times 0, right? So 11 times 0 is going to equal 0, so we get 52 plus 0, which equals 52. And then we have the starting value, right? Because if 0, right, the number of years that have passed since the initial decision. So if he just made it, it's going to be 0 years. So the logic works out. He would still have 52 pencils. Something to keep in mind, I believe it becomes relevant as college algebra goes forward. And we could have used any letter for the variable here, right? So we could have used, sometimes T gets used a lot. So we could have written. Hold on, I'm having a bit of a hard time with the software. I apologize. So we maybe could have written something like, 52 plus 11t. Sometimes we usually write the t in script because it can be confusing with the plus sign. A lot of letters get used in college algebra, but most of the time, E and I actually wrote this down here, E and I don't get used because those have more of a specific purpose. Now, I want to talk to you about the difference between expressions versus equations. Now, an expression has to have at least two terms, and expressions don't have an inequality nor an equal sign in them. So all the things I've written on the left here, these are all expressions. And equations must have an equal sign. So that's the big difference. And it becomes more relevant when you are simplifying and you're solving for x, because simplifying usually has more to do with expressions, right? So that would be something that you pay more attention to here. And then when they want you to solve for x, they're usually talking about these types of equations, these equations here. Now, it is important to note that equations generally contain at least one expression, sometimes even two. So, like, you can have an expression that goes something like 5x minus 3 equals 6 minus x, right? These are two expressions because you have an expression here and an expression here, because an expression has to have at least two terms. And speaking of which, this would be a good time to actually explain what a term really is, and as well as go into what the parts of an expression are. So, here you can see the parts of an expression. I did my best to color this for you so that you could see very clearly what the parts are. So the 3 here, the 3 in red, this can be thought of as the coefficient. And what the coefficient is it's the multiplier. It's a number that usually multiplies the variable. And the variable is the number that we talked about before. It's basically something that changes depending on what's put into it. And these variables come up a lot in college algebra. Now, the operator separates two terms, right? So the operator is either a plus sign or a minus sign. And the constant is a number that is not attached to the variable, which is how it gets its name, because the constant doesn't change. Coefficients, they multiply the variable. And the term on the left side here, so this would be, so 3y is a term, so this is a term, and 6 is a term. And this is because they're separated by a plus sign. Terms are separated by either a plus sign or a minus sign. Multiplication signs and division signs will not create separate terms. In fact, in college algebra, it's actually pretty rare to see multiplication signs and division signs when you're working with expressions and equations. They don't really come up as much. You see a lot of plus signs and minus signs, but multiplication and division does come up when you see variables next to coefficients, or just numbers next to numbers in parentheses usually, or when you see denominators. Denominators are big in college algebra, but we'll go more into that later. And something important to note here is that terms do inherit the positive or negative status of the operators that they're separated by. So I'll give you another example, right? So say if we had 4x minus 3. The terms would be terms, so I'll write that here. The terms would be 4x and minus 3. Or if you had, say, negative 5x plus 6, the terms would be negative 5x and 6. So this is important to keep in mind because this becomes relevant as the course goes forward. Now, I would like to go into the order of operations. And this is especially relevant when you're simplifying expressions. And we use an acronym named PEMDAS to remember the order of operations. PEMDAS stands for parentheses, exponents, multiplication, division, addition, and finally subtraction. So, I'll give you an example of how this works. We're going to simplify this expression. This is a pretty long expression, but I wanted to cover a lot with just a single expression. So, order of operations, first thing is parentheses, so let's start there. So I'm going to rewrite a lot of this stuff down here, just so that we don't lose track of everything. Plus 5. We're not going to start with anything here. We're not going to start by multiplying 3 and 4. We're certainly not going to add 4 and 5 together, because that would be a mistake. And we're not going to raise 3 or negative 3 to the second power either, because those are in parentheses. So the parentheses need to be dealt with first. And that's going to simplify to a positive 3. Now, I'm going to leave that in parentheses here because it's already been implied that they're being multiplied, because when you see a number next to parentheses like this and you don't see an operator, that is basically an indication that it is multiplication. So I'm just going to leave it like that. But we've essentially dealt with our parentheses because there's nothing left in them. And I'll leave the little 2 here. And then finally, we'll divide this by 3. Or we won't do that yet. I said we'll divide this by 3, but we don't do that yet because the next part of the order of operations is to deal with our exponents. And here we have 1. We have a little 2 up here, so we'll look at that next, but we'll write down everything first to keep track of it all. 3 times 4 plus 5, and then we'll square 3. Squaring means multiplying it by the same number. So that's going to turn into 9, because 3 times 3 equals 9. So 5 times 9, and finally we'll put this division sign here with the 3. Now we're going to do our multiplication. So we'll do 3 times 4. This simplifies to 12. We'll leave the plus sign here because we don't deal with that just yet, but we will deal with what's next to it, the 5 and the 9. That's going to give us 45 because we multiply those. And then we'll leave this here, and we'll do it next. We'll divide 45 and 3 next. So put the 12 down there, plus 45 divided by 3 is going to equal 15. So we'll drop a 15 here. And finally, the last step, addition. We're going to add 12 and 15 together. That is going to give us 27. Subtraction would normally be the last step, but because we had subtraction up here in the parentheses, we don't even have to worry about it because there's nothing left. So that's why the subtraction came first in this example, because it was in the parentheses. And the order of operations follows a different protocol in solving for x. Maybe you feel like you've done problems before, and you've subtracted first. That happens a lot when you're solving for x. But we're going to go into that in a different video. I just wanted to cover this for today. I don't want to make the lesson too long. Hopefully you learned something, and I want to thank you for watching. This is my first video, and this isn't my first video, but it's the first video in this series, and I look forward to making more videos. I hope you were able to learn something. Thank you very much for watching. And I plan on offering online tutoring if that's something you are interested in. Send an email to fixingfoundationsfoundation@gmail.com. You can see it on the screen right here. Thanks again for watching, and I hope we will both continue to grow as mathematicians.